All right, let's look at 6.2 Part A. Suppose Coke and Pepsi are perfect substitutes and right and left shoes are perfect complements. I have $100 for Coke Pepsi and I have $100 for right shoe left shoe consumption. And Part A of A says suppose Coke currently costs 50 cents a can and Pepsi costs 75 cents per can. Then the price of Coke goes up to $1 per can. Illustrate my original and my new optimal bundle with Coke on the horizontal and Pepsi on the vertical. Alright, so we have Coke, we have Pepsi, and let's see here. Originally, Coke is 50 cents a can and Pepsi is 75 cents per can. So the maximum amount of Coke at the original amount is 200 and the maximum amount of Pepsi is $100 divided by 75 cents is 133. Okay, so this is your original budget constraint. And then when Coke goes up to $1 per can, then now I can only afford 100 of it. So my budget constraint rotates inward like this. The slope here, P1 over P2, which is 50 over 75 cents, is negative 2/3. The slope here, which is P1 over P2, which is now $1 over 75 cents, is 4/3. Okay, now because we need an optimal bundle, we need to add in indifference curves. I'm going to draw them with green. It's perfect substitutes. They're going to look a lot like budget constraints. But let's see here. These goods are perfect substitutes, and so the MRS is -1 everywhere. That means that there are just lines with a slope of -1. So as you can see, the highest indifference curve that you could be on is this one that goes from 200 to 200, and this is your indifference curve for 200. And so your optimal bundle is here. That's the highest indifference curve you could be on. However, when this rotates inwards, it's actually now steeper than, see this MRS here is -1. This is actually steeper, and so the higher amount that you could be on, the highest indifference curve is right here, the one that goes from 133 to 133, and you'd actually consume all the way over here at this bundle. So that makes total sense. When Coke is cheaper, you consume all of Coke because they're perfect substitutes. When Pepsi is cheaper, you consume all Pepsi. Alright, let's look at the left shoe, right shoe problem. So we have, this is part B. We have right shoes, and then we have left shoes, okay? And I have $100 to buy both of them, and they're sold separately. The right and left shoes are priced at $1. So originally, what's the maximum amount that you can buy? Well, since perfect complements, you always buy them together. The maximum amount you can buy is 50 and 50 because they're $1 each. So 50, 50, this is the indifference curve you're going to be on. And your budget constraint would look like this. It would go from 100 to 100. Okay, so this is your budget constraint, but because it's perfect complements, you're always going to buy at the corner because that's the optimal bundle. And so this is your indifference curve where you have 100 level of happiness. Now, the price of left shoes increases to $2. So let me go ahead and draw the new budget constraint. So the new budget constraint is now, looks like this, because the maximum amount of left shoes you could buy is 50 because they're $2 a piece. Now I know that the new the new indifference curve I'm going to be on is here, okay? And what is that amount? Well, I think the easiest way to think about this is, what's the number at $3 per pair of shoes, right? $1 for right and $2 for left. That's $3. what's the maximum number of shoes you could buy? It's 33 1/3 pair of shoes. So this actually is at 33 1/3 on both of these. Okay? And that's your new optimal bundle there, 33 1/3. So it used to be 50-50, now it's 33 1/3. Okay, part C, true or false? Perfect complements represent a unique special case of homothetic taste in the following sense. Whether income goes up or whether the price of one of the goods falls, the optimal bundle will always lie in the same rate from the origin. And as you can see here, that's a true statement because the optimum bundle always lies on the vertex or on the corner of the perfect complements. And for part B now, it's asking you to write some utility functions. So let's leave this here for a second. I erased the one for Coke and Pepsi, but those are perfect substitutes. The appropriate indifference curve for perfect substitutes is anything that's additive. So you could have utility of x1 and x2 is equal to x1 plus x2. That's perfect substitutes. And that would therefore, if you recall, make my earlier indifference curves labels. It would make them 133 and 200 like I labeled them earlier. On this, the left shoe, right shoe example, these are perfect complements, so you might want to try something like the minimum of x1 comma x2. This will give you perfect complements. And then if we label them, this label would be the indifference curve. Oh, this was an error. This label would be the indifference curve for 50 shoes. This would be the indifference curve for 33 1/3 pair of shoes.